Azure Site Recovery is a comprehensive native disaster recovery solution enabling replication and recovery of workloads across different geographic locations. By leveraging this service, organizations can maintain business continuity during major disruptions. For participants of the AZ-104 Microsoft Azure Administrator course, this topic builds on prior knowledge of Azure Monitor, log configuration, and alerting to illustrate how insights and alerts integrate with your disaster recovery strategy. With site recovery, replica virtual machines can be automatically kept in sync in a secondary region, allowing minimal downtime through frequent and automated replication. Additionally, site recovery integrates with Azure Backup and Recovery Services Vault to ensure cohesive backup and DR management. In this section, we will explore how to plan, set up, and manage replication, failover, and failback scenarios to build a resilient Azure environment. Central to Azure Site Recovery are concepts like recovery objectives and replication policies. Recovery Point Objective, RPO, specifies maximum acceptable data loss, while Recovery Time Objective, RTO, defines permissible downtime. These metrics drive replication frequency and orchestrate failover. Site recovery supports replication for on-premises VMware or Hyper-V VMs, physical servers, and Azure VMs. Replication policies govern retention cycles, intervals, and other configurations affecting RPO. The Recovery Services Vault stores replication data, coordinates failovers, and tracks recovery points. By internalizing these terms, administrators can tailor disaster recovery plans to organizational risk thresholds. Azure Site Recovery's easy management interface simplifies the process of defining these core configurations, ensuring coverage for all infrastructure components. This foundation prepares you for real-world disaster recovery deployments. Azure Site Recovery follows a structured workflow that begins with creating or selecting a Recovery Services Vault to store metadata and replication data. Administrators then configure replication policies detailing intervals, retention schedules, and application-consistent snapshots. The workloads, Azure VMs, Hyper-V, VMware, or physical servers, replicate to a secondary region. In a failover event, production traffic is redirected to maintain service continuity. A subsequent failback restores the original environment once it is operational. Throughout these steps, administrators can monitor replication health, RPO compliance, and performance impacts via Azure Monitor. This holistic workflow is integrated into Azure's broader ecosystem, allowing you to catch any issues quickly. The result is a seamless DR approach linking replication, failover, and failback in one coherent process. Before deploying Azure Site Recovery, careful planning is crucial to match technical needs with organizational constraints. Begin by identifying critical applications, downtime tolerances, and valid data loss windows. These shape your RTO and RPO parameters, informing replication intervals and failover strategies. Assess your network to ensure enough bandwidth for continuous replication, and plan capacity so that the target region can handle a full workload shift when needed. Security must be accounted for, including encryption, RBAC roles, and data sovereignty requirements if working in regulated environments. Document each step meticulously to guarantee consistency across the environment. By treating site recovery as a systematic planning exercise, you enable a robust DR solution that aligns with your operational goals and resource allocations. Creating a Recovery Services Vault is the initial step in Azure Site Recovery. In the Azure portal, you select the appropriate subscription, resource group, and region, then provide a descriptive name consistent with your organization's standards. Once provisioned, the Vault offers a centralized interface to configure replication and manage failovers. Previously, you used Vaults for backups. Now, you extend that concept to support replication of VMs and on-premises servers. You can optionally enable encryption to secure Vault stored data. Configuring notifications ensures administrators receive alerts for failures, warnings, or critical replication events. Integrating with Azure Monitor further streamlines oversight, allowing you to visualize replication health and performance. Establishing a well-structured vault sets the stage for effective and efficient replication and failover processes. Site recovery works with Azure VMs, VMware, Hyper-V, and physical servers. For Azure VMs, navigate to the vault and enable replication, selecting an appropriate replication policy. On-premises environments require a site recovery provider on Hyper-V or VMware hosts, along with agent installations for physical servers. Connectivity must be verified to ensure continuous data transfer. If safeguarding high-importance workloads, consider application-consistent snapshots for transactional harmony. Ensure your platform agents are updated, firewall rules are correct, and any name resolution dependencies are addressed. Tagging source resources is a useful way to manage budgeting or capacity tracking. Properly configured source environments provide the backbone for an automated, dependable replication cycle, ultimately reducing complexity during failover and failback scenarios. Next, administrators define specific replication settings within the Recovery Services Vault. These settings determine target location, storage type, standard or premium, and snapshot consistency levels. A replication policy may extend beyond simple intervals to include application-consistent snapshots, which preserve disk and in-memory states for critical databases. Retention policies determine how many recovery points to store. Administrators might tag replicated items based on environment types, such as production or staging. Once policies are in place, initial replication begins, drawing data from source to target. Progress monitoring in the Vault's replicated items interface highlights any misconfigurations or bandwidth constraints early. Precise replication configurations assure data integrity and performance, building a stable core for your DR architecture. This thorough approach helps ensure a validated replication process throughout daily operations. For a successful failover, the target environment must mirror critical aspects of your primary site. Typically, the target is a secondary Azure region configured with parallel networks, subnets, and IP ranges. Some organizations replicate domain controllers or DNS servers to maintain authentication services in a failover scenario. In on-premises setups, a secondary physical site or alternate Azure subscription can serve the same role. Resource providers like Microsoft, Compute, and Microsoft Network should be registered and active in the target subscription. Pre-configuring elements like load balancers or network security groups reduces friction when a failover occurs. This careful preparation ensures that your DR environment can support immediate workloads, minimizing backlog or service interruption, and sets the stage for a controlled, rapid transition. With replication configured, Azure Site Recovery lets you perform test failovers without affecting live traffic. During a test failover, replicated VMs are spun up in a separate network, allowing you to verify application behavior and data consistency. This validation checks that network security groups and DNS settings are properly routed, ensuring dependability. By analyzing logs from a test failover, administrators can detect misconfigurations or performance bottlenecks and refine runbooks or recovery plans as needed. Removing the test environment afterward does not impact the continuous replication to the secondary site. Regular testing fosters confidence in your DR processes, confirming that the entire solution, from source replication to secondary provisioning, is ready. Periodic test failovers during maintenance windows can prevent unexpected surprises in real-world outages. In a real disaster, failover execution in Azure Site Recovery is designed to be intuitive. Administrators open the Recovery Services Vault and choose the failover type, planned or unplanned. A planned failover gracefully shuts down source VMs, syncing final changes. An unplanned failover bypasses this step if the primary site is already down. You may select a specific recovery point for further control, especially when multiple snapshots exist. Azure automatically creates target VMs, attaches them to the designated network, and logs each step. After failover succeeds, workloads run in the secondary region with minimal downtime. A record of every process is available, aiding post-event review. Since replication relationships remain intact, you can later transition workloads back when the primary environment recovers. This approach ensures a consistent and smooth workflow for addressing critical outages. Failback returns your environment to the primary site once it is back online. Azure Site Recovery facilitates this through the reprotect feature, reversing replication to the original location. In a planned failback scenario, administrators confirm the primary environment is fully restored and synchronized to avoid data discrepancies. The failback process reestablishes the original site as the production environment while continuing data replication from the secondary region until cutover is complete. Scheduling the failback during windows of low user activity helps minimize disruption. Post-failback reviews verify that applications and services are running correctly in their original infrastructure. Recovery Services Vault logs offer insights on each step, enabling quick identification of issues. By methodically handling failback, you ensure a smooth transition back to usual operations with minimal risk of data loss or extended downtime. Continuous monitoring ensures Azure Site Recovery functions correctly and adheres to SLAs. Through Azure Monitor integration, administrators gain real-time views of replication health, capacity usage, and failover readiness. Setting up alert rules allows immediate notifications if replication lags exceed defined RPO thresholds or if a failover test fails. Action groups automate responses, like generating support tickets or running scripts. Historical metrics inform adjustments to policies over time, proving especially valuable for capacity planning in multi-VM deployments. On-premises diagnostic log from the site recovery provider can diagnose connectivity or agent problems. By centralizing all logs in one solution, you can proactively spot anomalies. Effective monitoring spots potential issues, like high disk I/O or network stress, early, preserving a smooth DR environment and reinforcing year-round operational reliability. For administrators, troubleshooting Azure Site Recovery often involves verifying configurations, resources, and permissions. Check logs in the Recovery Services Vault and Azure Monitor for detailed error messages. Replication delays or failures may stem from insufficient bandwidth or disk I/O saturations. If replication hangs, confirm that the VM agent is properly installed and that relevant firewall ports remain open. In on-premises scenarios, ensure Hyper-V or VMware hosts are registered and agent software is current. DNS misconfigurations can also hamper replication, so confirm name resolution across both source and target networks. Validate runbooks for any mistakes in failover sequences. When in doubt, Microsoft support and official documentation can guide additional diagnostic steps. By methodically reviewing each part of the replication chain, from local agents to Azure networking, you can efficiently resolve issues and maintain smooth failover capabilities. Beyond more typical scenarios, Azure Site Recovery supports deeper customization. Multi-tier applications can leverage recovery plans that orchestrate the failover order of individual VM tiers. Integration with Azure Automation enables pre- and post-failover scripts, automating tasks like halting front-end services or updating DNS entries. Additionally, Azure Dev/Test Labs can host ephemeral environments for dedicated DR drills. Pairing site recovery with Azure Traffic Manager allows automated routing of external traffic during an outage. Some deployments utilize PowerShell or Azure CLI-based scripts to manage replication at scale, involving hundreds of VMs. While advanced features offer precise control, they also demand rigorous documentation and regular testing. By picking the right enhancements, you can tailor your DR strategy to business-critical processes, ensuring a smoother, more dependable response to potential disruptions.